So guys, I'm going to take a minute and go over uh, the notes for Venn diagrams and just how we apply that to basic probability. So I'm just going to be going kind of line by line for the notes I'm going to give you tomorrow in class. My wife's not feeling too well, so she needs a little help around the house. So um, I won't be in, but this will be your notes, and we'll just work on Venn diagrams and probability and how that applies to what we did before. Okay, so basically what we have is in the beginning of the notes, we got this little uh, scenario where we're building our own Venn diagram, and it says 17 people own cats, 15 people own dogs, 10 people own cats and dogs. Take a minute to draw a Venn diagram relating these sets together. Okay, so what we're going to do is I'm just going to draw a little area right here, right? And I'm going to say, okay, one circle we got cats, one we got dogs. Okay, so I'll just say cats and dogs, right? Okay, so it says 17 people own cats. So the biggest mistake people like to do, well, actually, you know what? I want you to pause this video real quick, and I want you to take that information, draw your own Venn diagram, and we're going to check it against mine in just a minute, okay? So go ahead and pause and do that. But a big mistake people make while doing this is when it says 17 people own cats, they go, okay, I got it. I put a 17 right here, okay? Please don't do that, okay? We want to look at that spot that says 10 people own cats and dogs, right? So if you look at this Venn diagram, this is what we call the intersection. That's the cats and dogs. So we're just going to draw a 10 right there, okay? Now, if 17 people own cats, I can just draw a 7 right here. And now you can see that there are truly 17 people in that circle, right? And 15 people own dogs, so that would leave a 5 right here, right? Now, here's what you have to consider, right? We have 17 plus 5 is 22, right? There are 35 students, and so 22 are accounted for here. So that means there are people that don't own cats or dogs. So out of the 35, we have 22, right? So we just need 13 more right here. And that should be our 35, okay? So 13 and 7 is 20, 35, yeah. Okay, so there's a Venn diagram, right? And this is all the people that are in this group or class or whatever it may be, okay? So question, a couple questions about this is how many people owned only cats? Well, if you look at this, 7 people owned only cats, right? How many people own only dogs? That's 5, right? And how many people own neither cats or dogs? Well, that would be that 13 down there, okay? Okay, now the group cats and dogs, where it says there, like, remember, this is our and symbol, that's a union, right? Or that's an intersection, sorry. And this is our or symbol, that's a union. The U is the or, this is the and, right? So the set cats and dogs would be these people right here. If I said cats or dogs, that's actually all these people right here. And we'll look at that in just a moment. But let's answer some questions right here, right? So the first question is, what's the probability I randomly select a student from the class that owns a cat? Okay, so we look at this right here. How many people own a cat? Okay, 17, right? Out of 35 total, right? So the probability of cat would equal 17, 35, right? That's probability randomly select a student that owns a cat, right? Okay. The next question says, what's the probability you randomly select a student that's only a dog owner, right? How many people only own dogs? If you look at that, it's 5, right? So 5 out of 35, or we could say that's 1/7, right? Okay, let's look at the next question here, see if we can figure this out. What's the probability you own a cat or a dog? Okay, cat or dog. So if you look at this Venn diagram, if you want the probability of, let's say, probably a cat or dog, right? Cat or dog. Well, that means either one's favorable, right? So you could have a cat, you could have a dog, you could have both, right? So if you added up all these right here, 17 plus 5, right? That'd be 22. Your answer would be 22 out of 35. That's your answer, right? Now, let's apply what we learned last week with the formula or, right? So cat or dog, those are inclusive events because there are people that own cats and dogs, right? So remember how this works. The probability of a cat would be 17 out of 35, right? Probability of a dog would be 15 out of 35, right? Okay, so that's 32 out of 35, right? Minus the probability of cat and dog, which is 10 out of 35. You notice we get the same exact answer, right? So if you like those formulas a lot, you can still use them because it all checks out, right? So cat or dog, right? There you go, 22 out of 35, right? Okay. The next question says on your notes, what's probably an ancestor that owns neither a cat or dog? So the way this looks is like this. Oh, well, I'm not going to write not twice, sorry. So when you see this little kind of apostrophe looking thing, that's like a complementary event. It's basically like the opposite, right? So if you see that, it's basically like, what's probably you don't own a cat or dog? Well, the answer, the people that don't own cats or dogs are these people right here. So that would be 13. Excuse me, 13 out of 35, right? You could also do this. If you think about it, probability someone owns a cat or a dog is 22 out of 35, right? The rest of them don't. So you're either gonna own a cat or dog or not, right? So those two events add up to 100%. So if you just took 1 minus 22 over 35, yeah, common denominator, you'd still get 13 over 35, right? So complementary events, remember, add up to 1, right? Okay, let's look at the next question. Ooh, okay, this is fun. What's the probability you own a cat given you own a dog? Interesting. Cat given that you own a dog. Okay, so when you say what's the probability that you own a cat given that you own a dog, you're not talking about everybody. Cat given dog means the probability that someone's a cat owner given that they are a dog owner. Okay, so you notice all these other ones we're doing out of 35, right? If I do this one, okay, cat given that you own a dog, right? Well, how many people own dogs? 15, right? So we're only talking about the dog people, okay? We're only talking about the dog people. So if I say what's probability on a cat giving you on a dog, you're only looking at this circle right here, right? How many in this circle right here own cats? Well, it's 10, right? So the probability you own a cat given that you own a dog is 10 out of 15, which would be 2/3, right? Keep that in mind now, 2/3, right? 2/3 is the answer. Now, remember that formula I gave you last week where it says probability of cat given dog would equal the probability of cat and dog over the probability of dog. You remember that? Probability of cat and dog over the probability of dog, right? Well, the probability of a cat and a dog would be 10 out of 35, right? Watch, 10 out of 35. Probability of a dog, look at that, it's 15 out of 35, right? See that? Well, guess what? 10 out of 15, still 2/3. See that? So you can still follow those formulas. They are still valid, okay? So let's look at one more. I think this last one, let me check. Yeah. What's the probability you own a cat given you don't own a dog? Okay, so probability of a cat given you do not own a dog. Okay, now, I'm not talking about everybody. I just want the lost souls that don't own a dog, okay? So look at this. How many people on this Venn diagram do not own a dog? Anybody outside of that dog circle, right? So I counted 20, okay? These 7 and these 13, right? So those are the people that don't own a dog. So we're talking about 20 people here, right? Okay. Out of those 20 people, how many own cats? Well, the answer is 7, right? So cat, given you don't own a dog, right, would be 7 out of 20. And I promise you that other formula would work. Probability of cat and no dog over the probability of no dog would equal 7 out of 20 as well. Okay, so all you're going to be doing today is working on some Venn diagrams and probability like the stuff we learned last week. And your assignment will be the 10 problems about the Sega Genesis and SNES and the arguments I got in as an 8th grader at Snellville Middle School. Okay, so please complete those problems, and I will see you Tuesday. All right, talk to you later.